Hi guys, so we're going to pick up with solving absolute value inequalities. So let's go ahead and get started with number one. So what you want to do first is make sure that the absolute value is by itself. Make sure the absolute value is by itself on one side. Now in this case it is by itself, so we don't have to manipulate or move anything before we go ahead and solve it. Now, once it's by itself, what we're going to do is we're going to set up two cases, a positive and a negative case. So we're going to set up a positive case and we're going to set up a negative case. Because we have to take care of the fact that the absolute value has basically two solutions, because like the absolute value of 2 is 2 and the absolute value of negative 2 is also 2. So we have to take care of that, setting up the positive and negative case. So when we do that, we just get rid of the absolute value and write your inequality. Now in the negative case, you get rid of the absolute value, but what you have to do is you have to flip the symbol and then negate the right side. So again, I flipped the symbol and then I negated the other side. So this was a greater than, and then it went to a less than, and it was a positive 1 in the original, and now it's a negative 1. So put a little note for this side, you want to flip and change the sign. So again, when you're doing a negative case, you want to flip the inequality and change the sign. So now we can go ahead and solve from here. So we're going to add 4 to both sides. So that gives us x is greater than 5. And then we're going to go ahead and do the same thing over here. So that gives us x is less than 3. Now, you have to basically determine whether this is an and or an or statement, because that's how you're going to write your answer, because we're going to have to do this in interval notation. So a lot of times it helps to do the graph first, because that'll help you to determine whether you have an and or statement. So if I do this on a graph, we know that 3 is going to go here and 5 is going to go here. You don't need to fill out all the other numbers in between, just make sure they're in order. So now if I was going to graph x is greater than 5, recall from interval notation, that's going to be an open circle and it goes to the right. If we're going to graph x is less than 3, again, it's an open circle, and less than means goes to the left. Now, if you're wondering why it's an open circle, remember that if it's a less than or greater than, it's an open circle. If it has the equal sign, it will be a closed circle. So now when you're looking at this, you can see that we have this gap in between these numbers here. So it's basically a broken gap in terms of the numbers between 3 and 5 won't satisfy this. That makes this an or statement, because basically your answer has to be less than 3 or it has to be greater than 5. It can't be both. You can't be less than 3 and greater than 5 at the same time, so it's an or statement. Now, how do we write that in interval notation? Again, I did this on a previous lesson. What we're going to do is we're going to graph this interval first, which means we're going, this is negative infinity all the way on the left side. So we're starting at negative infinity, going all the way up to 3, but not including the 3. So that's why we have parentheses. Remember, if you were including the value, it would be a bracket. Then we're going to do this interval here. We join it with the u for union. So we're starting at 5, and then we're going all the way up to infinity. And again, it will be parentheses for that. So this is the 3 different notations that you have. This notation right here would be your inequality. This is your number line, and then this is your interval notation. So you gotta make sure you can do all 3. All right, let's look at number 2. So this is already by itself, so we can go ahead and set up our positive and negative case. So we'll go ahead and do that. So then that gives us, get rid of the absolute value, so 4x plus 1 is greater than or equal to 9. The negative case, so 4x plus 1, flip and change the sign. Flip and change the sign. So now we can solve these. So we're going to subtract 1. So you get 4x is greater than or equal to 8. Divide by 4. So x is greater than or equal to 2. Let's do the other side. Subtract 1. So you get 4x is less than or equal to negative 10. divide by 4. So you get x is less than or equal to, I'm going to reduce that to negative 5 over 2. So now let's figure out if we have an and or an or statement. The best way to do that is to get a graph. So we're going to do the graph here. So negative 5 over 2 is going to be on the left side, and then positive 2 is over here. So if we want to do x is greater than or equal to 2, that's a closed circle, and it goes to the right. X is less than or equal to negative 5 over 2 is a closed circle, and less than goes to the left. So again, because these graphs, they're two separate intervals, there's a gap in between, it's an or statement. It's an or statement. So now how do we write this in interval notation? So first we're going to do this interval right here. Remember that all the way on the left side is negative infinity. So we're going from negative infinity all the way up to negative 5 over 2, but we're including it this time. So you got to put a bracket because it's a closed circle, so we're including it. Union, picking up with the next interval, starts at 2. So we're including the 2, so it's got to be a bracket. So 2 all the way up to, and again, all the way to the right is infinity. So that's how you write the interval notation. All right, let's look at another one. So looking at number 3. Again, it's by itself. So we can just go ahead and set up the positive and negative case. So we got 3x plus 2 is less than or equal to 5. In negative case, 3x plus 2 is greater than, flip, change the sign. 3x plus 2 is greater than or equal to negative 5. So now we can go ahead and solve these. So we have subtract 2. So 3x is less than or equal to 3. And then we're going to divide both sides by 3. So x is less than or equal to 1. Let's look at this side. So subtract 2. So 3x is greater than or equal to negative 7. Divide by 3. So x is greater than or equal to negative 7/3. All right. So now let's get a graph here and see what kind of statement we have. So if I do the graph, negative 7/3 is going to go over here, and then 1 is on the right side. So x is less than or equal to 1. That's a closed circle, and it's going to the left. Well, it's going to run into this. So let's take a look at the second one. So x is greater than or equal to negative 7/3. So that's a closed circle, and it goes to the right. So look what happens. Meets in the middle. This is an end statement. So if it's an end statement, because it meets in the middle, the way you're going to write this in inequality notation is going to be negative 7/3 is less than or equal to x, which is less than or equal to 1. So you can see the difference between this and the or statement. If it was an or statement, we would literally just write the words or between those two, but it's not. And you can't just write the words and between there. That's not how it's going to be written. They write it as a compound inequality, which is this right here. So all your end statements inequalities are going to look like this. Well, how do we do the interval notation? Well, again, we're just following the graph. So that's just going to be including the 7/3, so bracket. So we're going from 7/3 to 1 and including the 1. So when you have an end statement, you're just going to have one interval. When we had the or statement, we had 2 separate intervals. All right, so I am going to stop here just because of time. And I'm going to pick up with 4, 5, and 6, the other 3 examples. I'm going to pick up in another video because we're going to have to do something first before we solve that. So it's a good point to stop. So I will pick up with the next video.